This is topic 8-1, interpreting changes in slope and intercepts, day 1. Our objective is I can write the equations of lines giving parameter changes. So our essential question will be, how can I write equations of lines giving parameter changes? By the time we finish this topic, you should be able to answer that question. Our bell work today is we're going to review solving. And so you can take out your flow chart. Some of you may have it memorized, but if not, pause the video and take your flow chart out on how to solve equations. Our first step is to draw the line down the equal sign. Next, we look and see, do we have any parentheses? And yes, we do. So we must distribute. We'll take the number that's out front, that's the -2, and distribute it to the inside. So everything inside is being multiplied by a -2. So we have 8y, which nothing happened to, so it brings down. -2 times y is a -2y, and -2 times a -3 is a +6. That is equal to 18. Now we look to see if we have any terms we can combine on each side, and sure enough, on the left side we have an 8y and a -2y. They can combine to be 6y. Our next question is, do we have variables on both sides of the equation? No, we do not. So now we box the variable with its coefficient. We do the opposite of the term that's not in the box. That's the +6, so we're going to subtract 6 from both sides. 6 minus 6 is 0. We still have a 6y in the box. 18 minus 6 is 12. And our last step is we do the opposite of the coefficient that's in the box. That is 6 times y, so we divide by the number that's in the box. That leaves us with y equals to 2. We're going to do a quick review over slope, looking at graphs. If you have smart response clickers, you may use those. Otherwise, you can work on your paper. Number 1 says, which graph has a positive slope? So we're going to look at the two graphs. If I look at A, its slope is, again, how it changes from one point to the next. I can look at the graph and see that this is increasing or going in upward when I read it left to right. So this is increasing. This means it has a positive slope. So our correct answer is A. If I look at B, reading from left to right, it is decreasing, and so it is going to have a negative slope. Which graph has a negative slope? Again, starting from the leftmost point, and I read this is going down, so this is decreasing. B, starting at the leftmost point, go up, it is increasing. So the slope is how it changes, and this negative means going in a downward direction. So A, again, is the correct answer. It has a negative slope. Which graph has a positive rate of change? Rate of change is just another way of saying slope. So again, I'm looking for a graph that is increasing. Let's look at A. I'm moving down as I go across, so this is decreasing, which tells me a negative slope. Look at B, reading from left to right, my pen is moving in upward motion, so this is increasing, which tells me it has a positive slope. It is changing in a positive direction, so B is the correct answer. Which graph has a positive y-intercept? Y-intercept is where it crosses the y-axis. So in each one of our graphs, the y-axis is the one that goes up and down. If I start on my y-axis and go down to the point where it crosses, this point is in the negative part of my y-axis because I went below the x-axis. So this is negative numbers. On this, the second one, B, again, starting on my y-axis, I find the point where it crosses. This one is a positive y, and so B is the correct answer, has a positive y-intercept. Which graph has a negative y-intercept? We're going to do the same thing. On my y-axis, reach my point where the line crosses. This is in a positive y. B, I go to where it crosses. A, start of my origin. This is a negative y, and so therefore B is the correct answer, having a negative y-intercept. Okay, how did you do? Hopefully you did well. Let's start our topic. We're going to start with writing an equation based upon the description. Kelly wants to join Rhapsody for her music downloading. They charge a $5 registration fee and $1 per song. Write the equation that represents this situation. When we wrote these equations before, we started with what's the output, how does it begin, and then is it going to change in a positive or negative direction, and then times the input. So the way that we can figure out what the change is we can look for where it says per, because our change is going to be multiplied by the input. So I see a per here. This tells me it's going to be multiplied by the number of songs. So if I let X be my number of songs, I know my change is going to be $1 per song, or 1 times X. The charge of a $5 registration fee, that's how much I get charged initially. It doesn't change. And so my total cost then is my Y, or the output, and I'm going to take that $5 registration fee and add the $1 per song. So I can also change it around so it looks like the Y equals mx plus b form, putting the number with the x first and then my beginning last. This is now in Y equals mx plus b. M is our slope, and so our slope is 1, and our y-intercept is 5. Our second part says, what would be the new equation if Rhapsody changed their prices to have a $3 registration fee and $2 per song? So $3 is where we begin, and now it's $2 per song, so I know I'm going to multiply the 2 times x. I'm still adding, so I'm going to rewrite it so the x is first, so it's in y equals mx plus b form. I could have left it. Just recognize your m is always the number in front of the x. So our m is 2 and our b is 3. So what happened to the slope and the y-intercept between these two? My initial slope was 1 and now it's 2, so the slope increased with this price change. Y-intercept, it started off as 5 and now it went down to 3, so our y-intercept decreased with this change. This is what we're going to be talking about today when I talk about parameter changes. What happens to your equation when you change either the slope or the y-intercept? So we are given the equation y equals 2x plus 1. I want you to recognize what our slope is and what our y-intercept is. So I'm going to write the y equals mx plus b across the top. I recognize that the slope is always the number in front of the x. So our slope in this case is 2. Our y-intercept is 1. So what would happen if the slope was increased, or we increased the slope by 2? Remember that increase in our vocabulary means to add. So that means with our slope, we are going to add 2 to it. So our slope was originally 2, we're going to add 2 to it, and we get a final answer, or final slope of 4. It didn't do anything to our b, so our new slope is 4. Our y-intercept is still 1, so our equation is y equals 4x plus 1. Because we still want to come out with y equals mx plus b. Next thing says we're going to times the slope by 3. So the only thing that changes is the slope. We take our original slope of 2. We're now going to multiply it times 3, and we get a new slope of 6. So our slope is 6. Our y-intercept is 1. We have y equals 6x plus 1. Next one says change the slope to 1/2. So again, only our slope is being affected. So our slope, which was originally 2, now becomes 1/2. So our slope, new slope, is 1/2. Nothing happened with the y-intercept. It's still a 1. So we get y equals 1/2 x plus 1. We're going to times the y-intercept by 4. Times means multiply. So we're only dealing with the y-intercept. Our original y-intercept was 1. We're going to times it by 4 and get a new y-intercept of 4. So in this case, our slope stays the same of 2. Our y-intercept is the only thing that changed. It became a 4. So our new equation is y equals 2x plus 4. Next one says to translate the graph down 3. If we are translating the graph down 3, this affects the y-intercept. If you think about how the graph looks, I'm going to draw it down here. My y-intercept is up here, going through, and I translate the graph down 3. I'm going to go down 3 spots to a new y-intercept. So when I translate down, I am actually subtracting. And we are subtracting from the y-intercept. So the y-intercept is the only thing that's being affected. Our y-intercept was initially 1. We are now going to subtract 3, and we get a new y-intercept of negative 2. So our slope is 2. That's the original slope. Our y-intercept is a negative 2. So our new equation, y equals 2x minus 2. Last one says to translate the graph up 2. Well, if going down means subtract, that means translating up means to add 2 to the y-intercept. So the thing that changes, again, only the y-intercept changes. It was originally 1. We are now going to add 2, and we get 3 as our new y-intercept. Notice we didn't do anything to the slope, so our original slope is still 2. Our new y-intercept is 3. Our equation is y equals 2x plus 3. Now we're going to go to some problems where both are affected, not just the slope or the y-intercept, but both. So we have a new equation, y equals negative 2x minus 3. If I look at my equation, writing y equals mx plus b, again, the slope is the number that's in front of the x. It tells us how our x changes. So we have that our slope is negative 2, and our b now is a negative 3. Our action, we want to times the slope by negative 1. So the slope is the only thing that changes. Our original slope was negative 2. We want to times it by negative 1. So negative 2 times negative 1 is a positive 2. So we have a new slope of 2, but our y-intercept is still the same. It's still a negative 3. So our new equation is y equals 2x minus 3. Notice how it is different than our given. Translate the graph up 2. This means we're going to add 2 to the y-intercept. So m, this is b now. Our y-intercept changes. Our original y-intercept was negative 3. We're going to add 2 to it. So negative 3 plus 2 is a negative 1. Our original slope was negative 2. It didn't change. Our y-intercept is a negative 1. So our new equation is y equals negative 2x minus 1. The slope becomes 2/3 and translates the graph up 4. So we have two things going on. First, the slope becomes 2/3. So our slope, which was originally negative 2, now becomes 2/3. So our new slope is 2/3. Next, we have to translate the graph up by 4. That means we're going to change the y-intercept by translating the graph up. B is originally negative 3. Up means go add. So negative 3 plus 4 equals 1. Our new b is a positive 1. So our new equation is y equals 2/3 x plus 1. Now we're going to increase the slope by 2. Remember, increase means add. And we're going to times the y-intercept by 3. So our slope is affected. It is increased by 2. So let's start with our original slope of negative 2. We're now going to increase it by 2. Negative 2 plus 2 is 0. Our y-intercept, we're going to multiply it by 3. So our original y-intercept was negative 3. We're now going to multiply it by 3. So negative 3 times 3 is a negative 9. Our slope is 0. Our y-intercept is -9. So our equation is y equals 0 times x minus 9. However, you will not see that on a multiple choice because 0 times anything is just 0. So we can then just say 0 minus 9 is just a -9. Your equation that you would see is y equals -9. You want to keep the slope the same and times the y-intercept by 5. So the slope stays the same. That means our slope is still a -2. The y-intercept, however, is times 5. So the y-intercept changes. It was originally 3. We're going to times it by 5. That gives us a -15. So our new y-intercept is a -15. And our new equation is y equals, the slope is still -2 times x and then minus 15. We want to take half of the slope and translate the graph down 1. So our slope is changing. Half means I'm going to multiply by 1/2 or divide by 2, whichever way you like to think of it. I think of it as multiply by half. So our original slope is -2. We're going to multiply by half. And -2 times half is a -1. And then translating down, down means to subtract. So our y-intercept, we start off our original is -3. We're going to translate it down 1, so subtract 1. -3 minus 1 is a -4. So our new slope is -1. Our new y-intercept is -4. And our new equation is y equals -1x minus 4. Another way that we could actually see this going on is graphically. So that we have a graph of a linear function as shown below. If the line is translated 2 units down, which equation will best describe the new line? So remember when we talked about translating 2 units down, we're talking about the y-intercept moving. And it's subtracting from the y-intercept. So if I look at my y-intercept here, it is at 4. So my original y-intercept is 4. And now I'm going to translate it down to units. So my new y-intercept is going to be 2 because I'm going to subtract 2. Let's see if that works on a graph. 1, 2, translate it down. And notice it didn't say anything about the slope changing, so the slope should still be the same. So first off, I can look to see where's my y-intercept equal to 2 on the problems or the answers that are given, and that looks like C. So just looking at the y-intercept, I could get rid of everything else. But let's take another look and see how else we can get rid of. If I read my graph again, starting at the leftmost point, I notice that I will be going in a downward direction or decreasing, so that means my slope is negative. If my slope is negative, then B is definitely out of the question because we haven't done anything. And C, the slope is negative, D, the slope is negative, and A, the slope is negative. But C is the only one that has a y-intercept at now 2, which it moved down 2 spaces. So this concludes our topic 8-1. Let's do a summary. The main thing that I do recall in writing equations with parameter changes the main thing is to understand if you translate up and down, that affects the y-intercept. Translating up and down affects the y-intercept. It will either be adding or subtracting to the y-intercept. Okay, we also knew increase means add. And I think the other thing we had was, I think times, you understand that means multiplication. So I'm not going to put that one, but increase meaning add was a good one. Okay, this concludes topic 8-1 notes. Good luck on your quick write. Sorry, on your quick check.